Culture media, preparation, sterilization, and storage. Like everything living, microorganisms too need nutrients, a source of energy, and certain environmental conditions for their growth and reproduction. The microbes have adapted to their natural environment to survive and thrive. In a laboratory, these growth requirements must be met artificially by means of culture media. A culture medium is basically an aqueous solution to which all the necessary nutrients required for the growth of microorganisms have been added. Culture media can be broadly divided into two major groups: liquid media, such as peptone water and nutrient broth, and solid media, such as blood agar, which is prepared by adding 1 to 2% agar to the liquid media. Besides these two, semi solid media are also used, which are prepared by adding zero point 0.2 to 0.5% agar to the liquid medium. Though liquid media can be fortified with different nutrients and permit growth of most bacteria, there are certain disadvantages as compared to the solid media. First, growths of bacteria do not exhibit special characteristic appearances and hence are difficult to identify. And second, isolated colonies cannot be separated from a liquid medium. Both these deficiencies can be overcome by a solid medium. On solid media, different microorganisms give distinct appearances in the form of colonies, which are very useful in identification. Also, solid media are indispensable for the isolation of pure cultures. That is, an organism can be easily separated and grown as a pure line, thus helping in identification. Culture media can also be classified as basic, enriched, selective, indicator, and transport. Basic or basal media. These are simple media which support the growth of microorganisms that do not have special nutritional needs. Examples are nutrient broth and nutrient agar. These are mainly used for the preparation of enriched media, for maintaining stock cultures of controlled strains of bacteria, and for subculturing of bacteria from selective media for performing biochemical and serological tests. Selective media. These media have certain inhibitory substances added to them which inhibit the growth of unwanted bacteria and only promote the growth of pathogenic or disease causing bacteria. These media are used for sites which have a normal microbial flora to prevent the growth of unwanted bacteria overcrowding the pathogenic bacteria. An example is DCA medium for dysentery bacilli. Indicator or differential media. These media have certain substances or indicators added to them which help to differentiate between bacteria, usually by a color change. An example is McConkey's medium, which produces red-colored colonies of bacteria which are able to ferment the carbohydrate present in the medium. In contrast, bacteria which do not ferment carbohydrate produce colorless colonies. Transport media. As the name indicates, these media are used to transport specimens from the patient's bedside or health centers to a microbiology laboratory. These are usually semi-solid media which promotes the growth of certain delicate organisms which might usually not survive the time taken for transportation of the specimen to the laboratory. These also prevent the pathogenic bacteria to be overgrown by commensal bacteria. An example is Kerry Blair's medium, which is used for the transportation and preservation of enteric bacteria. Preparation, sterilization, and testing of culture media. Aseptic techniques. All microbiological media should be prepared in a sterile environment employing aseptic techniques. A separate room should be dedicated for the preparation, pouring, and sterilization of the culture media. Disinfect the work area. Wash hands, wear gloves, lab coat, and tie your hair. Before preparing any medium, read the manufacturer's instructions on the bottle carefully. All glassware required should be sterilized. Keep the required amount of distilled water and the powdered medium ready before you begin preparing the medium. Dehydrated culture media. In the preparation of complex culture media, ready-made standardized dehydrated media can be used to ensure good performance and reproducibility. They are less cumbersome to prepare and also less expensive. A minimum of 5 dehydrated media are suggested for a basic microbiology laboratory. Nutrient broth is a broth base from which nutrient broth, cooked meat broth, etc. can be made. Nutrient agar is used to make blood agar, chocolate agar, etc. McConkey agar is used mostly as an indicator medium for gram-negative bacteria. Sensitivity test agar or Muller-Hinton agar is used for antimicrobial sensitivity testing. Deoxycholate citrate agar is a selective medium for growth of enterobacteria like Salmonella and Shigella. Preparation of dehydrated media. Dehydrated media tend to absorb moisture from the air and are sensitive to heat, light, and extreme changes in temperature. Storage conditions are usually indicated on the product label and should be followed carefully. The date of receipt and the expiry date should be noted on the label. Follow the storage conditions as indicated on the label, usually below 25 degrees centigrade in a dry area, away from direct sunlight, autoclaves, hot air ovens, or other heat sources. Use your stock in lot batch number order, that is, the product with the earlier lot or batch number should be opened first. Do not open a new bottle until the previous bottle has been emptied. Note on the label the date the container is first opened. After use, make sure the container is tightly closed and return it to the designated storage area. Order the medium in an appropriate size of container and according to the need of your laboratory. A large container which is opened several times will spoil the medium over time. Discard the medium if the powder has caked, if the color has changed, or if it appears abnormal in any way. Reconstitution of dehydrated media. Follow instructions for the preparation of culture media given on the label of each bottle. It is advisable to prepare 1 week's requirement only. Always use freshly prepared distilled or deionized water. Warm the water up to 50 degrees centigrade to quicken the dissolution of the medium. Rinse all glassware with the distilled or deionized water and make sure that the vessels are clean. Prepare the medium in a container which is about twice the final volume of the medium needed, so that the dry powdered medium can be adequately mixed. Open the culture medium container away from current of air or moisture. Wear a mask and gloves to avoid inhaling the powder and prolonged skin contact. Weigh the powder quickly, accurately, and without creating clouds of dust. Close the container as soon as possible. Pour half the required volume of distilled water in the vessel, then add the weight quantity of medium, mixing briskly for a few minutes. Pour the rest of the distilled water down the sides of the vessel to wash away any medium sticking to the sides of the vessel back into the solution. This is important as dry culture media powder, which does not dissolve, may not be sterilized in the autoclave and can be a source of contamination. Media containing agar should be heated first to completely dissolve the agar before autoclaving. Bring the medium to a boil without burning. Most culture media will require final sterilization in an autoclave at 121 degrees centigrade for 20 minutes, but it is important to follow the manufacturer's instructions as it may vary for different media. Do not adjust the pH of dehydrated media prior to sterilization. The pH of the dehydrated media is adjusted by the manufacturer so that after the medium is prepared, the pH of the prepared medium matches with the label specifications given by the manufacturer.